Okay, so let's do some review of previous stuff you've learned. Hopefully I did a good job of teaching it to you. Two of the things you should have learned in the past are the term SOHCAHTOA and c squared equals a squared plus b squared. Those are still true. Like, that doesn't change anything because we're working in radians. Okay? But the rule you need to know, though, is that they apply only to right angle triangles. And we're going to try to make right angle triangles wherever we possibly can. Okay? For example, on a circle like this, do you guys see how I've made a right angle triangle right here? Okay. Well, we could actually determine a point right here as an ordered pair, as an xy pair. If this guy right here was the angle right here, normally this side here would be known as the opposite, this side here would be known as the adjacent, and this side here would be known as the hypotenuse. But from now on, rather than calling them sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, we're actually going to refer to them as x and y, where this will be a y value and this will be an x value. And I think I showed you guys this last year, didn't I?
This is kind of like physics.
There's huge overlap with physics.
So you can, so the way you tell which is x and y.
X goes this way and y goes up and down.
So x will always be on the x-axis.
Yeah, and the y will always be on the,
Y.
I mean, it's not actually on the y-axis, but
Yeah, in the y.
it'll be in the y direction. Okay. Did I show you guys these formulas last year or not?
Yeah.
I did?
Somewhat.
Yeah.
Okay, so from now on, rather than going O and H and A, we're going to use X, Y, and R standing for the radius. That makes sense? Let's do an example. We did a lot of these last year. Before I do that example, by the way, if you have an angle that goes past 100 and past 90 degrees, what ends up happening is your X and Y, your X is now going in the negative direction. I feel like I showed you guys that last year as well. Hopefully that's review. So what it means is that you can have negative X's. Let's just go to an example here. Sorry, fast forward to this one. I'll come back to that if I need to. Okay, so let's say I give you a point on a circle of -3, -7. Whereabouts would that be plotted? Yeah, in terms of quadrants, 1, 2, 3. -3, -7 would go down here.
So is it like assuming we have like a 10-10 standard?
Sure, we could assume it's about 10-10, I guess, right? Does that make sense if I plotted it down there?
So then would you always take, like would you, yeah.
Okay, so let's work in degrees at least for right now. Approximately how many degrees is this going to be?
250.
Yeah, 250 sounds about right. I would say maybe in the 250-ish range. I mean, I know it's less than 270, that's for sure. I know it's more than 180, and it's probably closer to 270 than 180 based on how this is drawn. Okay. One of the things I had you guys do last year, a lot of them, is write out the different ratios. And there's actually 6 of them. The main ones are sine, cosine, and tan, so let's do those first. Sine would be equal to opposite over hypotenuse, but your opposite value now, this angle right here is your reference angle. Your opposite is now known as your y value. Your adjacent is now known as your x value. And your hypotenuse is now known as a radius. So if we want to figure out sine, sine is going to be opposite over hypotenuse, which is y over r. Does that make sense? So my y value is -7. Do you guys remember how to find radius? Yeah, say it louder, Trent.
7 squared plus 3 squared.
Square root, yeah, it's Pythagoras' theorem. So you could do 3 squared, 7 squared. Does it matter though that it was negative?
No,
Because you're squaring it anyways, right? So that would be 9 plus 49. So this thing is whatever the square root of 58 is. That's what your radius would be. So then we could say that sine is equal to -7 over root 58. That makes sense so far? What would cosine be equal to then? Well, cosine is x over r, but x is also going backwards, and x was negative 3, so it'll be negative 3 over root 58. And then tan is going to be opposite over adjacent, or y over x. So that would be negative 7 for y over negative 3 for x. If you have two negatives though,
Positive.
yeah, so you can just call it 7 over 3. That make sense so far? Last year I also made you guys do something I knew in advance would hopefully help with this year, and they were called the reciprocal relationships. And so I've got them on like another slide here. This is called a cosine, no, hang on, this one, cosecant, good, you guys remember this. Cant. This is called a secant. This is called a cotan. I guess cotangent. Okay. And the idea behind these guys is that if you used to have your answers, let me just rewrite them here, as negative 7 over root 58, well, this guy is just root 58 over negative 7. That's all. You just flip it upside down. Okay, a couple of reasons here. You could go like y over r and r over y, but to simplify things when you guys were younger, rather than teach you all 6 of these things, we typically teach you just 3. We teach you the sine, cosine, and tangent, because it makes it easier to keep track of. Also, your calculator only ever does sine, cosine, tan. Rather than having a button for like all 6 of them, it just does the 3 of them. The reason why is that it's really easy to change this from a cosecant to a sine. You just flip it upside down. Does that make sense?
So why would it be? How would they draw that?
Okay, let's say you wanted to solve for the angle then. That's the one thing we haven't actually done here. We actually solve for theta. So throw your calculator into degrees just to make it simple here. And let's solve for theta.
Yeah.
No degrees. We'll do radians in a second. So if you were to inverse sine negative 7 over root 58, I got negative 66.8.
Angle, right?
Is it safe to say that the angle should just be like absolute value?
Probably should be absolute value here. What does that angle mean in terms of this picture here then?
Would it be like negative 66 like down?
This guy right here
Oh, going this way.
would then be basically 66.8. Like this reference angle in here should be 66.8. Ignore the negative for right now. So then what's the entire angle? Well, add that to 180. And it was actually 246.8, which is really close to whoever said 250. Okay, because if this little guy in here is 66,
Oh,
we got to add the 180 to figure out the whole angle.
Why are we ignoring the negative?
Can I come back to that in a second? That is a good question. Let me do that in pieces though. Let's say we did this for cosine then. If you inversed cosine negative 3 over root 58, you're going to get 113.19. That doesn't make sense. Here's where that 113.19 is. That would actually be right here. This is 113.19. It's actually going the wrong way for us.
Wait. What did you just do?
Shouldn't it be negative?
I'll talk about positives and negatives in a
Oh,
second.
because you did second first.
How did you just get that one?
Okay, so like I said, cosine was supposed to be negative 3 over root 58. So I inverse cosined it and I got 113.
Shouldn't you be getting the same?
You should be getting the same thing. Here's why. That 113 was actually this distance right here. If you were then to take 113 and subtract it from 180, and like go say 180 minus that answer, you'd get that same 66.8 degrees. But what your calculator did is rather than finding the small little angle right here, it actually found the large obtuse angle instead.
Why did you do that all of a sudden?
Can you give me a second? I will explain that, I promise.
It's like when we did that last year, we would have done that, right?
I probably purposefully chose questions where this wouldn't have happened as much. Let Let me try it one more time with tan. Can you guys tan inverse 7 over 3?
What does tan, like when you inverse things, that gives you an angle?
It gives you the angle, yeah. 7 over 3. And do you see how this guy gives you the 66.8? So really, when you inverse sine, when you inverse cosine, and you inverse tan, they all kind of gave you the same angle. The cosine one didn't, though. The cosine one actually gave you like this large obtuse angle right here. But most of them gave us that 66 that went in here, which meant that all three of them gave us the same angle. If your calculator had a button for cotan, it would do the exact same thing. But why do we need a button for cotan? Let's just use tangent and flip it upside down,
Which is the same thing.
which will be the same thing.
Oh,
Okay. So in terms of having 6 of these things right here, you don't ever have to use all 6. Usually we just use 1. Right? You either use sine, or you use cosine, or you use tan. In theory, we could have used cotan, or we could have used secant, or we could have used cosecant. But why? It's redundant. It's kind of... Does that make sense? And that's the reason why you probably never learned about cosecant, cotan, and secant until last year, is because, to be honest, they're not actually that useful. I mean, if you can use secant, you can use cosine.
So why are we talking about them now?
Essentially, any triangle has like 3 sides to it. As a ratio, you could do a ratio of A over B, B over C, or A over C. But you also could do B over A, C over B, and C over A. Does that make sense? And so basically there exists 6 of them, but like we probably don't have to use them very often in solving problems.
do they all show you the same thing?
They all should give you the same angles though, yeah. Like if you were to do tan inverse or sine inverse or cosine inverse, they should all help you find the same angle.
And why did that cosine one give you a different angle?
Okay, let me talk about that for a little while because that is a twist. Let me go back in some notes here. Let me go back here. Back on this slide here, I mentioned that you can have negative numbers. The reason why you have negative numbers is because you're going like backwards into this direction. Okay. Depending on which identities you're using between sine, cosine, or tan, this guy right here in this angle would have a very similar reference angle. You guys see how like both of these reference angles could be the same as each other? But here you'd have a negative y and a negative x and r. What ends up happening then is that cosine, sine, and tan actually always have 2 answers. Let me see if I can illustrate that in a picture. Let me do it on this slide here. Say this angle here was 45 degrees. This angle right here, if it was like similar, would it make sense if I called that guy 45 degrees as well? Okay. Well, this 45 degrees is based on, for example, this could be based on a y value and an r value. Y and r would be sine. Would it make sense that y over r should be equal to like sine? I guess what I'm saying here, would it make sense that sine should be positive in this quadrant right here? Because you're doing positive divided by positive. Whereas x in this quadrant here, cosine would also be positive. But what happens in this quadrant here? Here when you have r and you have y, what happens to x? Becomes negative, which means that when you do sine, sine is still positive. And it's the exact same answer for this guy as it was for this guy. But cosine is going to be the adjacent, or x value, over the radius, and cosine will be negative. And what ends up happening is this answer right here and this answer right here are almost the exact same as each other, except one is negative. If this guy's 45, what would this angle right here be? Okay, let's test something here then. Let's type in sine of 45. Before I press enter, should it be positive or negative?
Positive.
Okay. Well, now let's do the sine of 135. Sine of 135 involves this y value over the radius, but both of them are still positive. If I press enter, I get the exact same answer. Does that make sense at all?
Mm-hmm.
Mm.
No.
You don't. When you do, are you in degrees or radians though? Sine of 45 and sine of 135? Put it in degrees. Now let me try cosine. Cosine of 45 should actually be positive, and it's actually the exact same number. And the reason why cosine is positive is because positive over positive remains positive. But what happens in this quadrant here? It should hopefully be negative when you test it out. So if you do cosine of 135, it becomes negative. Let me keep going here. If this angle right here then was 45 degrees, what would the whole angle be? 225. Okay. Well, let's talk about what happens to these guys right here. Here, your x value is negative, and your y value is negative. So sine should be negative, and so should cosine, because both of them are now negative. And so now when I test it in my calculator, sine of 225 is now a negative number. And when I do cosine of 225, it's also a negative number. Does that make sense? Last quadrant. Let's say we put a 45-degree angle right here. My x value is now positive, but my y value is negative. So then in this quadrant here, sine should be negative, but cosine should be positive. So one more time. In this quadrant here, sine is supposed to be opposite over radius. And since your opposite is negative, sine in this quadrant should be a negative number. But cosine in this quadrant should be positive because x is now positive again. This angle all the way around to here would be 315. So if I test that just to make sure, sine of 315 gives me that same answer but negative, and cosine of 315 gives you that same answer but positive. Okay, here's where the twist comes in. What happens if I work backwards? What if I want to inverse sine that 0.7071106 number? If I were to inverse sine that, it should give me an angle. Does that make sense?
Sure.
Here's the problem. Which angle is it going to give me? Well, it could give me any angle. When I do give this one, it gives me basically 45 degrees. But it could have given me 45 degrees right here. It also could have been this guy right here, though, because this guy right here was also that same value. And so what happens in your calculator is when you're looking for an angle, make sure I'm really clear here, when your calculator looks for an angle, it finds an angle. It might not be the right angle. So when we did a section of work right here, when we inverse cosigned this thing right here, it gave us 113.19. Your calculator found an angle. It didn't find us the angle we wanted though, because I can tell based on this guy right here, there's no way that angle is 113.19. So then I had to use some logic and say, well, where is that 113.19? It must be this amount right here instead. Does that make sense at all?
No.
Okay. You can get the same ratio of like that, what was that number? That 0.707. I can get that same value from doing angles in any of the 4 quadrants. And depending on what quadrant you're in, it's either positive or negative. If I then want to take that ratio and work backwards to find an angle, your calculator can only choose one of them for it to be though. And so it's going to be your job to use your calculator and figure out which angle is the correct one to use.
By using the different.
By like, by subtracting. Maybe let me try another example here. Okay. Give me an angle between 0 and 360.
207.
207, okay. $207 would be about this. What would the reference angle be for 207? 27? Okay. Here's what I want us to try then. In your calculator, find the sine of 207. So if you did the sine of 207, I get a negative number. Comma.
I just have a question about reference angles. Do we have to go to like the x-axis now, like we passed, or like we go to either one?
You like usually we're like this guy right here. We're going to the closest x-axis, so that's this one right here. But your calculator might find the angle going to this axis right here. Does that make sense? And so this is where your calculator may not give you the answer you're looking for, and you have to do another step.
Okay, so like when you say reference angle, you want to go close.
But yeah, we want the closest reference angle. Okay, the sine of 207 is negative. First question, should it be negative?
Yeah.
Well, sine is typically equal to opposite over hypotenuse, but this opposite value is negative. So that does make sense that it's negative. What if I completely undid my work there and I inversed sine my answer? Shouldn't it tell me the answer of 207 again?
It doesn't.
But it doesn't. It gave me the answer of negative 27.
Because that's
Because what it found was this guy right here was going backwards by 27. So then if you want to figure out the angle you want, you would then have to take that 27 and add it back to 180 to get back to your 207. Let me try another one.
Okay, so why did you sign 207?
Because Aiden gave me an angle of 207 just randomly, and I wanted to see what happened if I signed it.
Yeah. And what
I just
happened?
because I picked one of the three.
What happened?
when you sign something or whatever to something, what are you looking for?
Okay, well what that tells you is whatever the opposite over the hypotenuse is. So that tells you this guy, whatever this length right here is, divided by this length. It tells you what these two numbers were divided by each other. Now, I don't know what the two side lengths are, but does it make sense that they're negative though because this guy went down? Okay. Well, if I completely undid the work I did there, so like if I were to then inverse sine that number, I should get back to 207, but I don't. Because what your calculator did is it looked for an angle to solve for, and it actually found the closest one it could find. You know where else sine is equal to a negative number? Is over here. Because in this quadrant right here, the opposite is still negative, and the hypotenuse is still positive. And what your calculator did is it found this guy as negative 27 in this quadrant instead.
I have a question.
Yes.
Are there going to be instances where, like, because this one kind of worked out because it was negative 27, but we know that positive 27 has worked.
Yeah.
Are there going to be instances where it's, like, totally not right? We're going to have to look at it and be like, hey, obviously our calculator found the absolutely wrong.
Can I do another example here?
Yes.
Okay, let's do the exact same thing now for cosine.
Why is one side negative 27 and the other side positive 27?
Well, doesn't matter whether they're positive or negative. Okay.
It doesn't?
Not really. I mean, the angle, like this angle in here is
I'm so
27.
confused.
The negative 27, Nicole, just means that it went this way rather than this way.
So the
Clockwise
angle.
is negative. Counterclockwise is positive.
Let me try another example. I just picked sine as one of the three. Let's try another one. Let's try cosine. So take the cosine of 207. Before you press enter, though, cosine is supposed to be whatever the adjacent over the hypotenuse is. The adjacent would be right here. It's negative. So I'm expecting a negative number. So if I were to inverse cosine, no, not inverse cosine, just cosine 207, I'm going to get negative number. But what if I were to inverse cosine that answer? I should get back to 207, shouldn't I?
No, it's a
But
really weird
get
answer.
it back.
It gives you 153.
What is that?
And therein lies the question, okay, why in the world is it giving me 153? It should have given me 207.
You get back to 260.
Well,
Minus 180.
because, yeah, this difference right here is where that 153 came in. The reason why is your calculator found an angle that works. Do you guys remember the word coterminal?
It can be more than one thing.
Yes. Your calculator does not know which one you're looking for, so it picks the closest one, but it might not be the one you want. What your calculator did is it looked for an angle right here of 153 degrees and said, what you were looking for was a negative adjacent. This angle right here still has a negative adjacent. So it picked this guy as 153, but we didn't want the 153. So we have to use a little bit of logic and work backwards and say, well, 180 minus the 153 gives me that 27 in there. That makes sense?
Yeah,
That makes sense.
it's starting to make more sense.
Okay.
But wouldn't the 153 be on the bottom?
Sure, you could look at it that way too. Here's the 153 right here, meaning then that this is still 27 though.
Yeah, it does make it.
Okay, go take a 5-minute break here. This is a hard enough topic without a break. Okay, let me keep going here. Let's see that I can help make this make more sense.
That did make more sense.
It did make more sense? Oh. Please be patient, okay? This is a tough first start to the unit. Okay.
So what you're saying is the answer we get is not always the right answer?
Yes, that's what I'm saying. And we need to figure out how to make it the right answer.
Just do a little subtracting and adding?
That's what it comes down to, yeah. Yeah. It's not hard, it's just recognizing what's happening. Okay, find this slide right here. If you were to have an angle in quadrant 1, I don't care what the angle is, the x value is positive, the y value is positive. If the x and the y value are both positive, it means that every sine, cosine, and tan should be positive. So we can say that everything is positive in this quadrant here. But what if you go backwards into this quadrant here? Here, your y is positive, but your x is negative. So what that means then is sine is equal to y over r. Sine is still positive though. Even though this guy right here is negative, since this y is still positive, sine is still positive. But cosine and tan should be negative in this quadrant. In this quadrant down here, everybody's negative. Negative y, negative x.
How's tan part?
Well, because tan is opposite over adjacent, or x over y. If they're both negative, negative over negative makes this guy positive. And then in the last quadrant here, x is positive but y is negative, which means that in order to make something positive, it has to be cosine because cosine is adjacent, which is x. And since adjacent is still positive, you're still good.
Is the hypotenuse always positive?
The hypotenuse is always defined as a positive. Okay. Here's what this means then. There's an acronym that kids often learn. It's called CAST. C-A-S-T. What it means is that everything is positive here. Only sine is positive here. Only tan is positive here. And only cosine is positive here. And we can use that to help solve some problems.
Okay.
And I'd like to just hop into my problem that I've got way back here.
What's the A step
Everybody. Okay. Let's try to solve this question here. Maybe this will help put everything together. I'm going to tell you that cosine of theta is negative 0.4. Okay, let me draw a picture out here. Can you guys find this one? Sorry, I'm jumping everywhere. Cosine is negative 0.4. Where could cosine be negative? Which two quadrants?
Second and third.
Okay, let me show you why this would work. Over here and over here we could have negative. Because you're going to have a negative x value, a positive y, a negative y. So if cosine is adjacent over hypotenuse, adjacent is negative, there's hypotenuse. Or in this quadrant here, adjacent is negative, and there's hypotenuse. Do I care at all about the y value? Not when talking about cosine. Okay. Do you guys know how to make 0.4 into a fraction? Sure, 4 over 10 works. Sure, 2 over 5. So if I were to give you cosine of theta, would it make sense to call it negative 2 over 5?
Why?
Because that's what 0.4 is as a fraction. Well, what's my hypotenuse going to be then? 5. what is my adjacent going to be? Does that make sense?
Oh, yes.
So I'm just working backwards. I took the 0.4. I said 0.4 should be a fraction. So let's make it a fraction. It was 2 over 5. As a fraction then, that means that the adjacent and the hypotenuse should be negative 2 for adjacent and 5 for hypotenuse. Which means that I actually have two different angles. There's an angle here and there's an angle here. There's actually two possible answers.
Wouldn't they be the same though?
Well, they should be really similar. They're going to have that same reference angle. Can you grab the door again, please? Okay, now let's take our calculator and let's inverse cosine negative 0.4. Inverse cosine negative 0.4. Here's the problem. Your calculator doesn't know which angle you're looking for. So it's just going to pick you one of those angles. And it picked you 113.57. Well, that hopefully kind of makes sense. That means that this right here, let's just call it 114 to simplify things, is 114.
I got 1.98.
Are you in radians still by chance?
Why are we
Stick with degrees for just now.
Have we even started?
Yeah.
We're going to start converting to radians in a little bit.
Did we do this on Monday? No, we wrote this on Monday.
Did we start in radians?
Yeah, we did. We also switched radians.
We're going to go back and forth all the time though.
I missed that.
Okay, is everyone okay getting that 114 number? Here's what that means. Your calculator found an answer that somehow was going to be negative, and it picked the 114. But that's not the only answer that would work. If you were to go backwards 114 this way, what would the other angle be in this quadrant? So if you did like, say, 360 minus 114,
246.
about 246 should work. 114 should work going to here, but going all the way around to here, hopefully 246 also works. I'm going to test it for you.
If you were just looking for the reference angle though.
If you were just looking for the reference angle, it would be 66.
Yeah.
You could do that as well if you wanted. Let me test it. Do cosine of 114. This should equal about negative 0.4.
Yeah.
Why is it slightly off? Well, I rounded. But what if I did the cosine of 246? It also would equal the same thing. So there's two right answers,
Sweet. So it's like trigonometry.
Okay, wait.
like
is
quadratics. Yes.
that 114 degrees is from the 0 to the first side? Like,
So the 114 is from here up till here. This guy is 114 degrees.
but it's also from like the bottom too.
But you could also do this one going, I guess, backwards the 114 degrees right here. It would also work.
Oh, is that going to be the way that is all the time? Like the 114 on the top and then the 114 on the bottom, like they both like that?
That often works that way, yeah. That's a good
Okay.
trick. Okay, here's the kicker though. I didn't ask for two angles. There was a little bit of like a defining thing in here. It said theta has to be between pi over 2 and pi. Because your calculator is going to give one answer, but there could be more than one answer that works here, where is pi over 2 and where is pi on this diagram?
In the second quadrant.
Yeah, it's the second quadrant because pi would have been right here. No, pi over 2 would have been right here. And pi would have been right here. So this little notation right here is indicating that even though there are two possible answers, we only want the answer that lies in this quadrant. So therefore it's the 114.
Wait, what? No way. No, because that one goes out of that quadrant.
No, the 114 is the one between pi over 2 and pi.
It starts in the first quadrant.
Okay, but where does it end? It ends in this quadrant right here.
Oh.
Whereas this guy ends in the quadrant between pi and like 1.5 pi. So what it's basically saying is don't take this one here, X that guy out, and look for this guy here instead.
What is the other part for the ratio?
Okay, let me do that part last then. Let me just recap what we've done here. First, I plotted a bit of a graph and figured out where this thing could be negative, and I found 2 spots where it logically could be negative. I used my calculator to find the angle in degrees, just to make it simple. In degrees, I got an answer of 114, which is good, that works. But it's not the only possible answer that could get me a negative 0.4. Apparently 246 also works if I go like a little bit further around the circle. This thing right here though narrowed down which of the 2 angles I'm actually looking for. So now if I could maybe redraw it a little bit neater, because now it's getting a little messy here. I know I'm looking in this quadrant here. This guy was -2, this guy was 5, and I know that all the way around to here was 114 degrees. That makes sense? Now the question is, well, what are sine, tan, what are these guys equal to? What is sine typically equal to? Opposite over hypotenuse? Well, I have the hypotenuse, it's 5. Could I find the opposite value? Pythagorean theorem. So this time it'll be like 5 squared minus -2 squared square rooted. That'll be how you get this guy's value. Because you'll have to go hypotenuse divided by this guy. 5 squared minus 4 basically. So what is sine equal to? Sine of theta is equal to opposite root 21 over hypotenuse, which is 5. What's tan going to be equal to?
Opposite over adjacent.
Tan would be equal to opposite over adjacent, but opposite is now y, and adjacent is now x. So it'll be equal to root 21 over -2. Let's say I wanted to confirm that angle though. What if I were to inverse sine root 21 over 5? If I were to inverse sine this thing, shouldn't it give me 114? But what if it picks another angle? It actually picks 66.4.
Oh, that's the little angle in there.
That's this guy right here. That's 66 degrees right there instead. So my calculator gave me an angle, but it didn't give me the angle I was looking for. Make sure you close the bracket on the 21 before dividing by 5 like that. What if I inverse tan root 21 over -2? It should give me 114, but my calculator actually gave me -66.42
Oh, I did not get that.
for this guy right here.
Oh, I didn't put that in.
Okay. Again, your calculator found an angle that worked, but it just didn't find the one I wanted. So that 66.42 actually means your calculator found an angle down in this quadrant here. Well, you asked it to find an angle where tan was negative. Tan can be negative here, but tan can also be negative here, and it just chose a different angle to solve for. So you just have to recognize that that -66 just means this guy right here is 66, and work backwards to solve for 114. Does that make sense? So I guess summary of like the biggest thing kids struggle with is when you inverse to find an angle, your calculator will find you an angle, but it might not be the angle you thought you were finding. And then you have to work backwards and figure it out for the right angle. Maybe.
I just apologize to the periodic table.
It's okay. Laurentian forgives you.
So how did we go through like grade 10 and grade 11 only finding one angle and it was always the right angle?
Because does this seem slightly familiar to what we've done? But just now the twist is that could be angles in other quadrants. We more or less because I simplified it and only gave you equations that would have like an angle, like the angle you solved for was the angle your calculator would pop up.
Okay, so you just purposefully chose
Yeah.
questions. Okay.
Does that make sense?
Yeah.
To try to simplify things. Okay. There's always twists. Okay, let me give you an old diploma question. Let's see whether we can work through this together. This is an old question that they asked on the diploma back in the day.
Back in the day.
Back in the day. There's a lot to interpret here. So, first thing, I'm going to tell you that cosine is 5 over 4. Could you find the angle for theta? It might find you an angle for theta. It might not be the one we're looking for. But why don't you do that? Inverse cosine 5 over 4. What do you get?
What is cosine?
Oh, it
Cosine
doesn't
is
work.
adjacent over.
Over hypotenuse.
Somebody else is for it. Oh.
Did anybody inverse cosine 4 over 5?
Er,
What'd you get?
36.86.
Yeah.
Okay, why don't we call that 37 degrees for right now? So I'm just solving for theta here. I looked at this first thing right here and said, hey, let's solve for theta. Here's the problem though. That angle might not have been the actual right angle we're looking for. So now I'm going to start plotting this a little bit here. According to the CAST rule, C-A-S-T, I can look for cosine being positive here, and that would be 37 degrees. Or sine could also be positive way down here.
So it's in the fourth. Oh,
Okay, the next thing here, this information right here helps narrow it down for me. 3 pi over 2 and 2 pi.
that's a 34.
Well, this is where 3 pi over 2 is, and 2 pi is right here.
So it's in the fourth.
So we weren't actually looking for this angle here, we were looking for this angle here. So is the angle actually 37 degrees?
Yeah.
Well, no. Sure, we could make it negative 37 degrees. That would be valid.
Or
but we want
just
all the
2
way
Or we could go all the way around and make it
327.
327. Now, by the way,
3.3.
they may ask you this rather than degrees though in radians. So don't, like, to make it easier for right now, I'm trying to do this in degrees. But eventually we're going to have to do radians as well.
323.
Now I got to answer the question they asked though. They want to know what cotan of theta is.
Cotan.
Okay, so let's work backwards here. What is tan supposed to be equal to?
Opposite over adjacent.
Okay, tan is opposite over adjacent. So then cotan is going to be whatever the adjacent is over whatever the opposite is. So now I've got to figure out what the opposite and adjacent are in this triangle here. Ah, there we go. The adjacent is 4 and the hypotenuse is 5. So I know that, let me find another color here. This side right here is 4. This side right here is 5. Could we use Pythagoras' theorem to solve for the opposite side over here?
Oh, it's 3.
Well, hang on a sec though.
3, yeah.
I could write out 3, but this is why I really tried to
The 4 is
remind you of this last year. This 3 is actually going down though. So it's got to be negative 3.
Why? How did we get 3?
Well, you got to do 5 squared minus 4 squared square rooted.
25 to check 60
So, go ahead, Nicole.
Where did you get the 45?
The 4 was here and the 5 was here. Because cosine is adjacent over hypotenuse. So then I made the adjacent side 4, and I made the hypotenuse side 5.
Where's your theta when the 4 and 5? Okay.
There.
So then you just Pythagoras theorem.
To find 3. But I couldn't just call it 3, I have to call it negative 3 because it's going down.
So would we go second tan over 3 over negative 3 over 4?
We can do that as well. Can I do that in a second though? Okay. One more thought here then. What is cotan equal to? Well, your adjacent is going to be 4. Your opposite is going to be negative 3. And so the answer was D. Well, that's why they put like every possibility in there just to mess with you. Now, for Aiden's question here, could we reconfirm this angle? Now, can your calculator inverse a cotan?
No.
But it could inverse a tan. So if tan was actually equal to negative 3 over 4, take your calculator and go second tan, oops, inverse tan, negative 3 over 4.
Negative 3.
And it should give you negative 36.
Yeah. I thought it was 4 over negative 3. Or we switched it back to 10. Oh.
Switch it back to 10 now.
Then we did 10
I just said nothing.
And that negative 36 is basically that negative 37 that we already said that it was going to be back here. So it's this confirms that we went backwards by about 37 degrees.
Oh.
Does that make sense at all?
Ish.
Yeah, a little bit.
Okay. This is going to take a while.
That's for sure.
Okay, let me show you another old diploma question. Why don't we end with this? This will be the last thing we do today, and I'll finish the rest another day. Okay, the terminal arm of an angle passes through the point 8, negative 6, but there's like a k value involved there. Just to mess with you.
Can you just like, of course. Can you just ignore the K?
Sure, let's do that then. Let's ignore where k is. Where is 8, negative 6 going to be?
It'd be like
It's like in the.
Okay. Okay.
Okay.
If I were to ask you to estimate the angle here, it's going to be what? Between 270 and 360?
Yeah.
So in degrees, it's probably going to be 300 and something degrees. Okay. Well, what I could do though is I could label the triangle now and say that this side right here is 8 and this side is negative 6. Could we find the hypotenuse?
Yep.
How?
It's 10.
Pythagorean's theorem, yeah.
64
No, because this time you're adding them, right? Because this time you're looking for the hypotenuse, so you got to add them. No, because you're doing 8. Because it'll be 8 squared plus.
So 64 plus 36 equals 100 squared 90 is half. Maybe.
yeah, you do.
Is everybody okay minus Nicole there for getting a 10 on that hypotenuse? You got 10? Now, Heather, you suggested a while back that we ignore k, but can I suggest that we throw k back in now? Because we were ignoring that k temporarily, but I should probably bring it back again now. Okay, now it wants to ask me what is sine theta going to equal to. Sine of theta is equal to opposite over hypotenuse. What's my opposite value going to be to this reference angle right here?
What is sine of theta opposite over hypotenuse?
Opposite over hypotenuse?
I thought opposite over hypotenuse is sine.
It is.
Oh.
So sine of theta, sine of your angle, should be opposite over your hypotenuse. Can I reduce negative 6k over 10k?
No.
Yeah.
Well, 6 and 10 divides and
Negative
reduces.
3 over 5. Oh. Right? I was like, wait. No,
You still have to add the k though?
Well, but the k's cancel.
Ooh! So
So sine theta.
Where does it tell you what they're equal to? It doesn't anymore. You have to have those memorized. Like the SOHCAHTOA ones.
Yeah, those are in our formula sheet.
Are they on there?
I think so.
I thought you have to memorize them.
I thought that's all.
Yeah, they really are. No, they're not. No, they're really not.
Yeah, they are.
Okay, so what? Okay, so sine.
Well, they're on like.
Opposite over hypotenuse.
B.
What is so wait? Keep this.
Oh boy, and then we gotta go way back.
What is
Guys,
sine?
right there.
Is sine x like in terms of x and y?
Sine.
Of course I am.
So, and then half, CAH, adjacent over hypotenuse. Total.
Or I could just use my physics equation and have it.
Sure enough. So,
What?
You good? Okay, let me finish off here and then we'll call it a day. According to this angle, cosine is, guys, I'm almost done, okay? Cosine would be adjacent over hypotenuse. The adjacent here would be positive 8k over the hypotenuse, which would be 10k. Can those guys reduce?
Yes.
Well, 8 over 10 is 4 over 5 and the k's cancel. And then tan would be equal to opposite over adjacent. So opposite would be negative 6k. over the adjacent, which would be 8k,
3 over 4.
which they cancel, but it's negative 3 over 4. And that's where the negatives come in, because if you don't watch those negatives, they kind of tried to mess with you with these guys. It should be B.
Well, that's actually pretty easy.
So the
That
K's were
question
really
was actually
insignificant. They were just to screw you up.
The K's were there just to try to mess with you.
What does this mean if k is greater than 0?
Well, if k was less than 0, then now these numbers could be negative numbers, which means that rather than being, like, say, in this quadrant right here, they possibly could have been in this quadrant or this quadrant, because, like, you're somehow making your number negative.
Would we be able to answer this question if it wasn't k greater than 0?
That would make it a lot tougher. Okay, let me summarize what I was hoping to accomplish today. Let's see whether I did. You guys okay? Okay. When you're working with angles on like this grid, one of the issues that comes up is that these angles can occur in more than one spot. Like, say, this picture right here is a good example. Oh my God, I'm so distracted. Okay. If you are looking for an angle, your calculator has to find one angle. But it may not be the angle we were referring to. And so if your calculator spits out an angle of 45 degrees, that 45 degrees could have very well been right here. Or that 45 degrees could actually be this reference angle, meaning the whole thing was 225. And that's the twist that I need to add on to this year, is that we've worked with stuff like this in the past, I believe. But now it becomes trickier because you have to figure out which angle we're looking for, not just pick the one your calculator gives you. Okay. Eventually, we've got to start working in radians a little more as well, because I kind of did everything today in degrees to make it simpler, but radians is the next challenge. It is. And this is one of the reasons why I tried to do a lot of it last year, to try to help make it better, because this is like one of the hardest units there is.
It's the hardest math unit.
Probably, yeah.
I know, like, well, the other ones have been kind of hard
Probability
for
the
me,
easiest.
so woo.
You guys gotta be patient, okay? It takes a while to sink in. Like, a couple hours is not enough time. Okay,
Well,
so
once it
please don't freak out if
does.
you don't get it right now, because we need more time to let it sink in. Okay, any questions you guys can think of right now, or your brain's basically fried?
Pretty fried.
I gotta finish this tomorrow.
Oh yeah,
We're
tomorrow's
not gonna work on it.
No.
Although they look better on me.
Is probability the easiest one?
What was that?
Probability is the next unit the easiest one?
Usually, yeah. I leave it for last for that reason. Most people like
Oh,
it
so
best.
you give us like a nasty one and you give us a good one.
Hopefully.
But it's like
Depends on individual preference, though.